I'm Dave Lucy, a Senior Interactive Designer and Developer for Concurrent Technologies Corporation. And I'd like to talk to you guys a little bit about what we've been doing with emerging technology as it relates to STEM. And when I say STEM, I'm not sure if everybody's familiar with the term, but it's science, technology, engineering, and mathematics. And it's really a term that is applicable to schools and students. But if you look around the conference, everything that is happening here is really science, technology, engineering, and mathematics related. And it's a huge need. But we have some new rules that are out there. And I'm looking at them right now, and it's a mounting federal debt that we are all aware of, which leads to cutting the budgets, reducing the training and program dollars. And so there's pressure and there's an emphasis that we need to place on creating more commercially driven products that have a viability commercially. And then there's also the need to develop more relationships with the private sector and adhere and develop more COTS and less GOTS, in my opinion. These are kind of some of my opinions. So these are some of the things that we're looking at new rules. And then there's the need to develop the STEM careers and the STEM pathways among our students and develop a STEM workforce. So what the CTC response is, it's really focusing on these high growth areas, the areas that the students are attracted to, the STEM areas, the science, the technology, engineering, and math, and those really reside in mobile, 3D, gaming, virtual worlds, hybrid reality. These are the things that our students and kids are interested in. We want to emphasize and fund those types of projects and those types of initiatives to develop those deep internal capabilities and target those personal growths and seek new ways to do that. And so what has CTC been doing in that area? Well, we looked at it, and over the past 3 to 4 years, we've been helping students get smarter in the area of science, technology, and engineering and mathematics through bringing the students into our workflow. And we've been working with the state departments of education, the National Institutes of Learning, and various colleges and universities to develop a program to really help mine that next generation workforce and develop that. It's kind of like what I would call a farm team approach. And so we have a pilot project that I'd like to share with you. And that project really involves having students learn the whole process of game development, working alongside proven professionals, following a workflow and a methodology, but getting them excited and involved with those types of projects and initiatives that they're really gravitating towards. And that's what we're showing here on screen, where students can plug into a project that is statewide, where they learn how to develop structural elements for actual buildings that they interact in. Schools, malls, hospitals, hotels, essentially creating virtual worlds. What's the value of this? Well, first of all, developing and having virtual worlds that exist for their own schools allows us to plug that into a database for first responders. And now the first responders, rather than just having some blueprint that's locked in a room someplace that nobody knows about, it hasn't been updated, can now tap into a system on their iPhone, their iPad, or a mobile device, and they can virtually see the entire building as it exists. These buildings being constructed through a process that CTC has developed, they're encrypted. There's a whole process behind that I'd love to share with you and talk to you about. But again, the students are distributed various work products. They're provided with mentors and assistants that they can work with and learn from, and then ultimately they end up outputting products that we actually put to use. And we have a video here that I would like to share with you where we can see the Secretary of Education discussing this project and kind of just, again, summarizes the idea. Now the meeting where this video was extracted from involved the state leaders from Pennsylvania, all discussing this whole idea and this concept. How do we bring something like this into the high schools?
Innovation Camp, bring the blueprints of your high school. And we turn that high school into a three-dimensional at scale game. And with encryption and security efforts, make that available to certain people. And maybe take it to the level of saying, and some of the game pieces could be emergency responders. Could be your EMTs, or your police, or your 911 group, your fire. So when they come to a situation, we don't have whomever running around the district in a crisis saying, where's the blueprints? We know the place, they know the place. And those game pieces are in there, and that can be directed.
So here we have the Secretary of Education for Pennsylvania standing behind this initiative, backing it, describing it, internalizing it, getting the idea. So we're really talking about promoting the whole idea of STEM through this real-world, hands-on project approach. We're engaging and equipping the students. We're providing them with these various outlets, and it's really establishing that link between the education system and companies like Concurrent Technologies Corporation. So we're deeply committed to it. And it leads to, again, potentially safer schools and public venues. Now, I'm also going to show you next another clip of a video where we conducted a summer camp in West Virginia, and we spent 2 weeks with these students, and we showed them the inner workings of game development, media design, and plugged them into this pipeline to see if this is a viable possibility for students. And we'll see the video to see the results.
I think one of the best things that we could have done was to give all the students a feel for the technology field. And specifically, of course, all the kids are really interested in gaming. And for that specific reason, we brought in a group to work with all the students on the gaming industry, and it turned out to be absolutely phenomenal. Dave did an excellent job in getting all the students interested. So much interest came of it that we ended up taking 2 students to the governor's office. And at the governor's office, the students had the opportunity to talk with the governor and tell them about the opportunities that they had at the camp.
I kind of thought, okay, this is going to be, something, it's going to be fun. And then I really didn't imagine it'd be anything like this. I didn't think it would take me this far or anything. And then we just started to actually see it come together and see, like, okay, I can walk down the third floor hallway and say, oh wow, I actually created this in this program, and it's like something that I created, with my own hands. And it was really amazing to see how everything comes together.
It's overwhelming. I mean, I can't really express how I feel about this. I'm good with computers and everything, but nothing like this. And now that I've had the chance to get a little bit out of this program, I think it could really help me educational-wise.
It did change my life also.
Yeah.
I just thought I never really, I wanted to go to culinary arts, just couldn't. And just from all of the experience, learning how to do that, do the technology and learning business and all of the stuff at that camp, it's completely changed my view of business and technology. And I thought technology was so difficult to do, but really, if you learn how to do it, it's not difficult at all.
I can't say that I like it, I love it.
We started thinking a little bit more about how do we get the students engaged in the learning. And of course, gaming is a huge component of the everyday life of students. And then at the point that we actually had the classes ongoing, we started hearing a lot of success stories from the students. The students were stating things like, boy, if I learned this every day in school, I would just absolutely love going to school. Or if I had this technology at home, it would be really beneficial because they would have more opportunity to learn.
So as you can see, the students were definitely excited, engaged, and able, which is the big thing, able to do this with no problem. In fact, all the video that we showed and the examples that we showed in the video was developed and created by the students. Minimal effort from the side of the CTC staff, minimal training required. So these students are really eager and ready to go. The exciting part of it was they were willing to do this not only during school hours, but in off-school hours, because they're very moving from the feeling that we got and the interaction we got. They're moving too slow, quite honestly, with some of the classroom interaction that they have. They want to move in this direction. They want to learn how to develop mobile applications and how to develop virtual worlds and to create games. And some of the benefits that we see coming out of this program are having this database of three-dimensional assets that we could use for things like first response. But there's a variety of other applications that are available. Having this whole idea, this virtual layer, if you will, that sits over top of the natural world allows us to do pinpoint navigation on the insides of buildings. So it's like having the GPS for the building is the way I like to describe it. But it opens you up for so many other opportunities. So having a structural layout physically mirrored in the virtual world lets us move into things like hybrid reality when you start introducing these mobile devices that have the ability to read sensors and work with that type of data. So with this system in place, you could load up the software, have the building, the virtual overlay. You don't even need to physically see it like we're showing here. It just needs to provide you with the reference data so that we can then position an individual or products or devices or pieces or parts or whatever they might be or information within that virtual structure that could then become a window using your mobile device into a virtual world or into a hybrid reality, so that the data that you need to provide or the structural elements that need to be presented in a physical or virtual manner could exist and could absolutely be updated and maintained from any source. So what we're showing here really is an application where students get excited about gaming and about virtual assets and about that type of construction. But the real benefit, the real takeaway is that they get to work alongside of industry professionals such as we have at CTC, such as we have with our partners at Carnegie Mellon and other universities, to learn how to do this stuff. But the big bonus is that we then could start taking these assets that are modeled exactly to the square inch and start doing other stuff with them. So that's really what we see as a nice real takeaway here. And there's the obvious STEM benefits that are listed on screen. I'm not going to read those off. But I do have one other video to show before we open up questions.
So of all the things we can do in STEM, we're coming down to the technology and engineering, mathematics and science related to gaming. Of all the things we could do in gaming, we're coming down to the idea that we're going to focus on helping with school security, which may lead to municipal building security, that is sorely needed, but probably undoable in any other way.
And then just again, validating the approach, showing the interest. We had dozens of meetings with folks from every level, from the Department of Homeland Security all the way up to the State Department of Homeland Security, education leaders. We received backing from the Pearson Foundation and other learning institutions. So this is definitely an opportunity that we would love to see really take off on a larger scale. And again, there are so many other side benefits of this beyond just the students learning how to build games, that we really feel that it's a project that we really need to open up to the masses.